Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So Pythagoras says that a squared plus b squared equals c squared, and the c is the one opposite the right angle. So I'm going to label this a and b, so it would be 5 squared plus 12 squared equals c squared. 25 plus 144 is equal to c squared, and then 25 plus 144 is 169. And then we're solving to find out what c is, and we're just going to square root both sides. So square root of 169 is 13, so c is 13. The important thing to realise in this question is that we know a female has been selected, so we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power 16 times 9 to the power 46. Now when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40. We just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440. So the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. When proving two triangles are congruent, and congruent means exactly the same, we're going to have one of 4 answers. Either side angle side is the same, angle angle side, or angle side angle. Side 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 are the same, or they have the same right angle, hypotenuse, and side. This question doesn't have a right angle, so we can cross that out. It has 2 lengths, so 2 sides, but not 3, so we can cross that one out. It only has 1 angle, so we can cross this one out. So we're looking to see whether it has the same side, then angle, then side. So here we've got 13 as a side, then 139 as an angle, then 6 as a side. 13 as a side, 139 as an angle, and then 6 as a side. So they have the side, angle, side. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100. Because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now, it says how many bread rolls can we make? Now, we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be minus 36 equals minus 2x. I'm going to now times, or divide everything by minus 2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. There are a few different ways of finding out products of prime factors. I prefer using the bubble technique. So we just write the number out and we put a bubble around it. And we split that number into two numbers. So we find two numbers that multiply together to make that number. Now, I always pick the smallest that I can on the left-hand side. Now, the smallest I can think of is 2. And so 2 times 22 is 44. And now we think about 22, and that's 2 times 11. Now you might be thinking, why have I put the 2's in red? The reason why I've put them in red is they are prime numbers. We can't do another thing for the 2. Well, we can, it would be 2 and 1, but we'd be there all day doing 2's and 1's off the 2's. So we leave it as they are, and 11 actually is a prime number itself. So if I'm going to keep up with the theme, I can have that in red as well. Now, notice it says product of prime factors. So the prime factors are 2, 2 and 11. But the word product means times. So it's 2 times 2 times 11. Notice they're in ascending order. So it's 2 times 2 times 11. Now, if we were asked to do it in index form, we would write it as 2 squared times 11. So when we're asked to find the position, we're basically finding out what n is. And we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides, because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the 4th term in the sequence. And you could write it out. You could put n equals 1, n equals 2, n equals 3. Just keep going till you get to 39. Or we can do the method we've just done, which is solving it. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions. So 2.84 over 4 times 10 to the power of 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be -2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right, so green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, that will be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So the way this formula works is we have M, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here because all of these are congruent parallelograms, and we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we're going to be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here, so that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. When we multiply two surds together, so here we've got root 6 and we're timesing it by root 7, we can actually just multiply the numbers together, so that becomes root 42. And so our answer will be root 42. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into two. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half A plus B times the height. And the two parallel sides are on the left and the right. So it's going to be half times this part here, which is 40, plus this point here, which is 160. And then the height is actually the width. So the height is this bit here, so it's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide, and again 160 tall. So 3 times 160, which would be 480. And so we need to work out the total area. And we do that just by adding the two together. So 200 plus 480, which will be 680. The first thing to notice is we actually have two radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees, and this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in, and we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. If we count the squares for 0 to 10, we count that there are 8 squares. And to get from the frequency 4 to 8, we times by 2. And so each of these will be multiplied by 2 to find out how many squares there are. But we're actually going backwards, because we're going to count how many squares there are, and then we're going to try and work out the frequency. So for this second one, there are 12 squares below this line, and then these two here are 1 square. These two half squares count as 1, and these two count as 1. So it's going to be 12 plus 2, which is going to be 14. So 14 squares. Now, to get from the frequency to the amount of squares, we times by 2. So obviously the other way around, we divide by 2. So that would be 7. And counting the next squares, where it's 6 high and 2 across, so that would be 12. And so we're going to divide by 2 to find out the answer is 6. So the frequencies are 7 and 6. You're expected to be able to draw a sine, cosine and tangent wave. And here we're asked to work out what y equals cos x looks like on a graph. Now cos x starts at 1, goes down to 0, then goes down to minus 1 at 180, then back up to 0 at 270, then back up to 1 at 360. But don't just join it up with straight lines. That will not get you any marks. You've got to make it look like a wave. And this is not the easiest thing to do, but they are very forgiving over how you do this. As long as it goes through the points, and as long as this bottom bit is a U shape and not a V shape, then normally you will get the mark. So although that doesn't look perfect, that would definitely get the marks. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay, and then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that would be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here, but we know what k is now. So it's y equals 3,430 over x cubed, and that actually is our answer. So the frequency is kind of equal to the frequency density times the class width. And I say kind of because it's actually a proportional relationship. The frequency density doesn't have to be that value, it can be twice the value or half the value. But we're going to assume it is because we can check whether it is by the value given to us in the question. So going through each of the groups, the first one is 0 to 10 and it has a frequency density of 0.2. So we're just going to do 0.2 times 10, which will be 2. The next one has a width of 20 and the frequency density goes up to 0.8. So 0.8 times 20 will be 16. And the last one is a class width of 20 and it goes up to 1.2. So we're going to say that that frequency is 24. So if you do 24 plus 16 plus 2, you actually do get to 42. So we know that that is frequency equals frequency density times class width. Okay, now it says to estimate the amount of rocks that were greater than 15 kilograms. So we're going to draw a line up from 15 kilograms. And we're looking for all the values that were to the right of that line. So we know that there are 24 definitely, okay, because all of that bar is to the right of that line. And we've just got to work out what proportion of this bar is to the right of that line. Well, it's 4 squares wide and we're looking at 3 of the squares. So it's going to be 3/4 of 16. So the amount we're looking for, so rocks, is going to be 3/4 of the 16 plus the 24. So the 3/4 of the 16 will be 12 plus the 24, which will be 36. So we need to start here by rationalising the denominator, because notice that the answer it wants is not in a fraction. So we're going to write out the question, which would be √8 plus 50 over √2, and we're going to times top and bottom by the surd at the bottom, which would be √2, and so we're going to have √2 brackets √8 plus 50 over, and then √2 times √2 is just going to be 2, and we can multiply out these this brackets. So √2 times √8 is √16, which is actually just 4. So it'd be 4 plus, and then √2 times 50 is 50 √2, all of that over 2. And then we can divide top and bottom by 2 to get rid of the fraction. So that'll leave a 1 at the bottom, or just get rid of the fraction. 2 here. Now notice you've got to do all 3 terms. So we've got to divide this by 2 as well. So our answer will be 2 plus 25 √2, and it won't be over 2 anymore because we've got rid of that, so it's just not going to be a fraction. And so A would be the 2 and the B would be the 25. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19. So they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences, and so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence, and we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. the sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence, so what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in. It's not a problem. So we can just rewrite this function as y equals x over 10 minus 11. And we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides. And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. So we're going to need to complete the square to be able to answer this question, but the first thing I need to focus on is this 2, the coefficient of the x squared. I want to make sure that x squared doesn't have a coefficient, or has a coefficient of 1. So we're going to start off by just removing or dividing out that 2. And we're going to do it from the x squared and the x term. So we're going to be left with the x squared plus, and that's 14x. And we just leave this plus 5 at the end. That plus 5 really only ever comes into use at the end. Now we're going to complete the square here. So that will give us brackets x plus half of the x coefficient, which is 7 squared. And I'm just going to expand that quickly here. So x plus 7 squared is the same as x plus 7, x plus 7. And when we expand that, we get x squared plus 14x, which is good. And then we get plus 49. Now this bit here is the bit we need to remove. So what I'm going to do here is just take away that 49, because we don't really want that 49. Close bracket, plus 5. Okay, now I'm going to expand these brackets and to have the 2 next to the x plus 7 squared. And 2 times minus 49, which will be minus 98, plus 5. And then all we need to do now is add the minus 98 and the plus 5 together, which should be minus 93. The m part will be the 2, the p part will be the 7, and the q part will be the minus 93. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.